Okay, guys, ready for lesson 7. Now, these are kind of like jumping around things. We're not really on a topic here, but this just kind of goes back to inequalities. And we never really grasped linear inequality as far as lines go. So, I wanted to show you this. This is just something I wanted y'all to make sure y'all have seen before you get to Algebra 2, because I know you're going to have to do inequalities with lots of different graphs and things. So, I'm just trying to get y'all prepared the best I can with what little bitty time I have. So what I've actually done is I have actually taken my examples from the actual worksheet that y'all are going to do for this lesson. So if you want to go ahead and have that worksheet handy or some paper out that you're going to do to turn in for your assignment, then that would be a good idea, because that's what I'm actually going to do. I'm throwing you a big bone today. So I'm going to actually work 3 or 4 problems from the worksheet for you guys. So that means that you only have like 8 or 9 or so to do on your own. So that's good. I'm just trying to help you guys out as much as possible. And y'all can still send me questions about any of the others that you have, and I'll be glad to help you with those as well. So get that out of the way. So let's just remember inequalities. We have the symbols less than and greater than, and less than or equal to, and greater than or equal to. So it's been a hot minute since we talked about those. I actually think we talked about those in our first unit that we did together back in January. So it's been a hot minute, and a world crisis and everything else in between. So remember when we graphed those on a number line, we would do open circles for greater than and less than. And if they had closed circles, then we said that that solution was included, and we would do filled in circles. Well, when we graph lines, we're going to actually do dotted lines for less than and greater than, and we're going to use solid lines for when they have or equal to. So a dotted line if it's not or equal to, a solid line if it is or equal to. Now, so this is a lot like graphing lines. We do want it to look like slope-intercept form before we graph it, so we practiced that some last week. And so that was good that this is kind of familiar to that we have just went over that. But when we do inequalities, we're not just looking for a line. The solutions is not just on a line, it's actually in a region. So it's not just one set of small line of points, it's actually a whole region or an area of points. So that will make more sense after we work this problem. So we're going to do number 2 first. It's on the worksheet. And this one is already in slope-intercept form. It looks like y equals mx plus b, except for obviously there is not an equal sign. There's a greater than sign. And that does not say or equal to, so that tells me that this line is going to be dotted. So after I do my y-intercept and my slope, I'm going to make a dotted line. So my y-intercept for this line is +7. So I go up to +7 on the y-axis. 1, 2, 3, 4, 5, 6. I miscounted. 1, 2, 3, 4, 5, 6, 7. Okay, so that graph goes up to 8. So that's good to know. And my slope, so there's my y-intercept, and my slope is -1/2. So I go down 1 to the right 2, rise over run. Now I'm not going to make a solid line here. I'm going to make a dotted line. Okay, because it said or equal to, or did not say or equal to, so it's not equal. So this is just a boundary line. So you make a dotted line. Do not make a little short squatty line. Make sure that line is long. It's okay that it goes over the graph or goes outside the graph a little bit because you got all that white space. Now, what that line is actually a boundary line. It has separated this coordinate plane into 2 regions called half planes. So there's actually a half plane up here above the dotted line. And then there's actually a half plane. Hang on, I'm trying to erase that line I just made. And there's this down here is also what we call a half plane. Now I know that these don't look like it's half and half because of where the line is, but just think about lines and graphs are actually infinite. So it actually is a half, okay? Because they're infinite. There's no measurement to them. So, but that's what they're called, is a half plane. So we don't know yet if the solutions are above that line or below them. So what we have to do to find out where the solutions are is we have to do a test point. Okay, we have to pick a point and test it out. So I'm going to pick 0, 0. That's usually the easiest test point to use. The only time you can't use 0, 0 is if 0, 0 is on our boundary line. And our boundary line is that dotted line, so we're not anywhere close to it, so we're good. So we pick a test point, okay? I'll just lay this out. And our test point is 0, 0, okay? Well, a test point has an x value and a y value, right? So what we're going to do is we're going to plug 0 in for x and 0 in for y into our original inequality there, okay? So in for y, I put 0, and then I have greater than negative 1/2 times x, and x I'm putting 0 plus 7. And I'm going to check it out, okay? 0 is greater than, well, negative 1/2 times 0 is 0, and 0 plus 7 is 7. So that is saying 0 is greater than 7. That's not true. That's false. 0 is not greater than 7. So that means this area down here is not the solution region. Okay? So if your test point gives you something false, that means the solutions must be on the other side of your boundary line. So you're going to lightly shade with your pencil. And y'all, this is where you can have fun with it. Y'all are at home. Use a highlighter. Use a magic marker. Use a crayon. You just don't want to like bleed through your paper onto your mom's furniture. She might not like that. If we were in class, we'd probably use highlighters or colored pencils. And our solution is this area over here, because the test point down there gave me a false statement. And if the solution down there had given me a true statement, then that would be the solution region. But this area up here that I'm coloring yellow are my solutions. So you're going to color that up there. I don't care. You can use your pencil and shade. As long as you can still see that you have a dotted line there, okay, then that's fine. But you need to color or lightly shade. I prefer you lightly shade so we can see what's going on with the graph above there. But if you have like a light colored marker, that's okay. Highlighters work good because you can still kind of see through them. Color pencils are a lot of fun. Like I said, if we were doing this in class, I promise you I'd give you a colored pencil and we'd have lots of fun. All right. So let's do another one. So that one was actually in slope-intercept form for us. That was really easy. Let's do one that's not in slope-intercept form. So this one says x minus y is greater than 5. This is number 5 on the worksheet. So I believe this is still on the front page. So first thing I have to do is make this look like y equals mx plus b. Okay? So I'm going to subtract my x. So then I have negative y is greater than negative x plus 5. And I'm going to stick a 1 there just to help me out. And then that y is not all the way by itself yet. It's being multiplied by negative 1. So I need to divide everything by negative 1. Well, if you can remember about inequalities, one thing that happens when we, I canceled out, that when we divide by a negative is we have to flip our inequality symbol. So make sure you remember to do that. If you divide everything by a negative, you flip your symbol. So this is not y is greater than anymore. It's y is less than. And negative 1 divided by negative 1 is a positive 1x. And positive 5 divided by negative 1 is negative 5. All right, so now it's in slope-intercept form. My y-intercept is at negative 5, so I go to negative 5 on the y-axis. 1, 2, 3, 4, 5. Okay, my slope is 1, so I'll put it over 1 and get 1 over 1. So I go up 1 to the right 1, and you can do that more than one time like we did last week if you want to keep your line straight. This says less than, so that's a dotted line. So we're going to use a dotted line. Make it a nice long line. Don't make a little short squatty line now. Can't be handling that, especially when we have to color, okay? So there's my nice long line. I'm going to make my dots a little bolder. You can see them. Just make sure it's dotted, not solid, okay? All right, so now we got to see which half plane has the solutions. So I'm going to test 0, 0 again. Now, when you test 0, 0, It's okay if you plug it in right here where you got it in slope-intercept form, or you could actually plug it into the original problem. And I think that's what I'm going to do. So I'm going to test point 0, 0. That means 0 goes in for x and 0 goes in for y. So 0 minus 0 is greater than 5. So 0 is greater than 5. Nope, that's not true. That's false. So that means everything where 0, 0 was false. So all these points up here above the dotted line are false. So that means the points that are true are actually these points below the dotted line. So if you get a true statement, you color where your test point was. If you get a false statement, you shade the other side. So if your test point is true, you shade the side where the test point was. If it's false, you shade the other side. Okay? That just takes practice. So if y'all have any questions about any of those that are on your worksheet, please, please, please send me a message. Okay? I want to help you. I am tired of doing second grade math, so please send me a question. All right, number 10. I think I boo-booed. Oh, okay, number 12 does have or equal to. Okay, so yeah, I thought I hadn't given you any examples with an or equal to, but my last one does. So we're going to do number 10 just because it looked like those numbers were kind of big and it's not in slope-intercept form, so I just wanted to help you out as much as possible. So let's do that one. I want to get it to look like y equals mx plus b. So I need y by itself, so I'm going to subtract 12x. So that gets me 8y is less than negative 12x plus 24. And then I'm going to divide all my terms by 8. So that gets me, I'm not flipping this time because I'm dividing by positive. Y is less than, I'm going to reduce that. They're both divisible by 4, so negative 3/4. No, that's not right. Negative 3 over 2. Sorry. 3 over 2 x plus 3. So there's my equation in slope-intercept form. So my y-intercept is at positive 3 on the y-axis. I don't know why stuff keeps popping up on me. Sorry, guys. Touch screen is touchy. And then I go down 3 to the right 2, so that actually is on the x-axis. And that's says less than. It doesn't say or equal to, so that's a dotted line again. So here's my boundary line right here. Okay, make it nice and long. Put arrows on it. So now I have a half plane up here and a half plane down here, and I have to decide which one of those half planes I'm going to shade to show my solutions. So I'm going to test 0, 0 again. It's just a good one to use. All right. So there's 0, 0. I have put a blue X there. I'm going to use the original again. Again, if you would like to, you can plug it in where you got it in slope-intercept form, but I've kind of made a mess there, so I'm going to use my original. So I'm going to test with 0, 0. So I'm going to say 12 times 0, because that's my x, plus 8 times 0, which is my y, is less than 24. 12 times 0 is 0, plus 8 times 0 is 0, is less than 24. 0 is less than 24. Yep, that's true. So that means 0, 0 is part of my solutions. So what I will do is take my pencil or my color or whatever I want to use. I'm going to use green this time. And I'm going to shade the side of that boundary line that includes 0, 0. So if your test point comes out true when you test it, then you shade it. If it's false, you shade the other direction. So this part that's coloring green on your screen is the part that was true. So you can go and do number 10 now. You have all the work, and there's the correct answer. Just make sure I can see the dotted line, okay? I need to be able to see that boundary line. And I didn't really color. It actually goes all the way up against it. So I'm going to go back and fix that. Your OCD teacher. Okay. So there you go. So I just wanted to do number 12. Number 12 is and number 11 are probably the quickest to graph if you memorized. So I have told you guys over and over and over again to memorize that x equals a number is a vertical line and y equals a number is a horizontal line. So on number 12, we got the line y is less than or equal to 1. Okay, so there's y and a number. So that means it's a horizontal line. So I go to the y-axis at 1, and I'm going to draw a horizontal line. Now I got to check for solid or dotted. That says or equal to, finally. So this one's going to be a solid line. So if it says or equal to, you do a solid line. Let me circle that again. If it says just less than or greater than, you use a dotted line. So that means everything that's on that line is included in the solutions. Okay, let me erase my circle so you can see the problem. Now I still use a test point. And my test point is 0, 0 still. So there we go. Marked it with an X. This is so nice. Look, I just have to plug in a Y. I don't have an X. And my Y value that I'm plugging in is 0. So 0 is less than or equal to 1. True or false? Well, that's true. 0 is less than or equal to 1. So that means where I have my test point, all of those solutions on that side are true. So that means I color where 0, 0 is. So I'm going to color everything below my solid line. So all of those points in my blue area are solutions. The points on the line are solutions. Okay, so if your boundary line is solid, that has solutions as well to this inequality. If it's dotted, that means it's not part of the solution, but they're just part of the boundary. So I know some of this is kind of confusing, so please let me know if you need to have some questions. If you want to see me work another one, please shoot me a message. I'll be glad to. But I'm here for you guys if you need anything, and I miss you. I'm sitting in my classroom right now doing this lesson, and it's very lonely. And I miss you guys. I miss your chatterbox. I miss all the sound effects that I get from allergy season, and I hope y'all are doing well. And I'm getting sentimental, and I'm going to start crying, so y'all want me to shut up anyway. So y'all have fun doing your assignment. Hopefully doing some of these helped you, so now you don't have as many to do. Have a good rest of the day. I love you guys.